So here I am coming here to discuss the JEE Main 2026, 26 January Shift 1 paper of physics. As far as paper is concerned, it will be on the same theme which was in the last year. So you can consider it in between the easy to moderate range. Since it is a memory based test paper, so some values might be different from the actual paper, but the main thing is you need to understand the concept and the theme of the paper, which is going to be followed for the next coming test also. So straightforward, I am coming to the solutions directly, and let's see. So like as you can see, the first question, the rod of mass m and length L is attached to the two ideal string. Find the tension in the left string just after the right string is cut. So as we can see, like in the diagram also, these ends we will consider the ends. This A and B point will be the end. So string is attached to the ends. Okay, string is attached to the ends. And now right string is cut. So when the right string is cut, if I make the free body diagram of this rod, then at point A there will be tension T, and at the center there will be mg. So I consider this point as A, this point as C. Of this question I am solving with respect to center of mass. So I am going to write down the torque about center of mass, and that will be always the right way. Because though we can write down the torque equation about point A also, but not in all the cases. If suppose if this string is making some angle, then our equations will be different. So always choose the center of mass for writing down the torque equation. It will always be giving you the right solution. So what will be torque about C? So about C, we will see that there will be torque of mg is 0 and torque of tension will be T into L by 2, the perpendicular distance, which will be equals to I into C alpha. Right? So this is giving you T into L by 2 is equals to ml square by 12 into alpha, which means the first equation which you are getting is T is equals to ml by 6 alpha. Now also when we make the constraint relation about A, so you see that the motion of A cannot be in the vertical direction. So if I see at point A, if this rod is having the vertical acceleration Ay, why only in the vertical direction? Because the net forces on this rod is only in the vertical direction. So clearly at this instant your Ax is 0. That means this rod is having the acceleration in Ay direction. So when I see the acceleration of point A, it is having Ay and it is having L by 2 alpha, R alpha, which is L by 2 alpha. So that's why for the acceleration of point A, which we can write down as Ay minus L by 2 alpha, which is equals to 0, we are getting the constraint between Ay and alpha as Ay equals to L by 2 alpha. So in this equation, I can replace L alpha by 2 by A, which is giving me ma by 3. Now second equation, when you make the force equation, the second equation will be mg minus T is equals to m into A in the vertical direction, and now we can simply replace this ma by 3t by the help of the equation 1 and getting our answer 4t is equals to mg. That's why t is equals to mg by 4. So this is the answer of the first one, mg by 4, option B. Move to the next one. Which logic gate is given in the figure? So as you can see that, I will just make the Boolean algebra here. This is your A bar. It is a NOT gate, so it is A bar, it is B bar. This is A plus B. This is A plus B, A bar plus B bar and bar. And now again it is not, so what is your final output? C. C will be A bar plus B bar, bar and this is not, so again this is a double bar. Now this double bar will cancel, so it will be A bar plus B bar, which is AB bar by De Morgan. So clearly you can understand that this is AND and bar is there, so it is NAND. So it is a NAND gate. So very simple question. Directly by looking at this, you can interpret. Move to the next question. This is the question based on unit and dimension. And though this is a Bernoulli equation which is given to you, as you can see that P plus half rho V square plus there is another unknown term, right? Either you can follow by the Bernoulli equation that this is the energy per unit volume, or otherwise simply you can say that it will be also following the principle of homogeneity. So each and every term, there are three terms, each and every term is having the same dimension. So by principle of homogeneity, what we can say? We can say the dimension of P is the same dimension as A by B T square, which is the same dimension as half rho V square. So I will not consider this multiple terms, rather than I will take simply pressure. So what is the dimension of A by B? You can simply say it is the dimension of P divided by dimension of T square. Now they are the general terms. Pressure dimension is M L minus 1 T minus 2 divided by T2. So it gives you M L minus 1 T minus 4. So again, this question belongs to in easy category, right? So let's move to the next question. And they are not lengthy also. Till now, whatever questions we have discussed, they are quite direct questions. They are not taking much of your time. There are some questions in this test paper which is needed little calculation also. But most of the questions are basically direct question or very single concept use question, not very multiple concepts use question, which is expected in JEE Mains also. So as per the theme, they are going on track, like whatever last year, whatever we are expecting from JEE Main paper, it is going in the same way till now. Next one. As I told you, this is a memory based question. So here also, we have create this question by the memory of the student, but later on this is not the objective type question, this is a integer type question. So we have to find out the answer in integer of this question, and there is also a doubt that this is either 1 minute or 1 second. So I will solve this question by 1 second. So as you can see in the circuit, that this is 1 by 2 and 2 by 4. So clearly you can see that it is a Wheatstone bridge, balanced Wheatstone bridge. That means this one we don't need to consider. And they are talking about the heat produced for external circuit. So this one is considered to be the internal resistance, and external circuit will be only this AB. So if I ask you what is the resistance across AB, then since it is a balanced Wheatstone bridge, the upper branch is having the R equivalent as 3 and lower is having 6. So overall 3 and 6 is in parallel. They are giving you 3 into 6 by 9, which is equals to 2 ohm. So R across AB will be 2 ohm, and R equivalent of this entire circuit will be R plus R, RAB plus small r, then this is equals to 3 ohm. So with the help of this, we can find out the current in the circuit, which is going to be 9 by 3, which is equals to 3 ampere. Now, as you can see in the question, what is given? External circuit. So they are not interested in the entire heat generated. They are interested only in the heat generated in this external circuit. That means for that thing, we can simply write down heat generated in 1 second. So I am taking 1 second. In some of the sources, you may see that this is 1 minute. So as it is memory based question, so the datas are not clear. But yes, you need to understand what is the concept which we are using here. So heat generated means power is I square R into T. Since they are talking about in external only, means in AB circuit only, that means I will take RAB. So now this is going to be 3 square into RAB is 2 into time is 1 second. That's why answer is 18 joules. So it's integer type, that's why it is 18 joules. Okay, let's move to the next question. Again, very simple calculation, direct question based on Wheatstone bridge. Move to the next question. Now this one. Alpha particle having kinetic energy 7.7 MeV. Now this is little calculative, but still again here also, as it is memory based, these options are not the correct option. These options are not the correct option. So in various sources you will get the various values. Let me put the correct values for this. Just 1 minute. Okay, so the values are 0.4 into 10 to the power minus 13 meter. Similarly, this is 0.3 into 10 to the power minus 13 meter. This is 0.5 into 10 to the power minus 13 meter. And this is 0.7 into 10 to the power minus 13 meter. Now let's see what is the concept which we are using for this. There is an alpha particle. Now you all know alpha particle means helium ion. So it is alpha. Alpha particle is having the charge plus 2e. It is being projected with some kinetic energy, which is given to you 7.7 mega electron volt. And there is a nucleus which is fixed, a gold nucleus which is fixed with the atomic number 79. So if you see what is the charge on this, it will be 79 into E. That is the charge it is having. This is your capital Q. This is fixed. Nucleus is considered to be fixed. So now when it is projected from a very large distance, they are asking the closest one. So as it is approaching towards the nucleus, it is being retarded, and finally for R minimum, its final velocity must be 0. That means clearly we can see that when it is at infinity, these two charges are interacting, and their potential energies keeps on increasing where the kinetic energy is decreasing and finally becomes 0. So we can simply apply here conservation of energy, that loss in the kinetic energy is equals to gain in potential energy. Loss in the kinetic energy, magnitude wise it is 7.7 MeV, which is going in the potential energy gain, and that potential energy gain is K into QQ by R minimum, as initial one will be 0 because of large distance. So for this R minimum, we can simply use this calculation. Now this is 9 into 10 to the power 9, Q is 79E into 2E divided by, I converted this into 7.7 into mega is 10 to the power 6, and for electron volt, again we multiply E. So 1 E and 1 E cancel, and you put the value of E as 1.6 into 10 to the power minus 19, and then you will get this is 0.295 into 10 raised to the power minus 13 meter, which is approximately 0.3 into 10 to the power minus 13 meter. So the correct answer is B here. So since because of memory base, these values are slightly different, so avoid this. Okay, simple question based on conservation of energy. move to the next question. Okay, this question belongs to capacitor, and again the direct definition of capacitor. So you have studied in the capacitor with electric, with dielectric, without dielectric, as well as the partially filled dielectric. So here also directly, if I say when it is without the dielectric, what will be your general expression of capacitor? In parallel plate case, it is epsilon naught A by D. But when it is partially filled with a dielectric slab of thickness T, then the expression becomes C dash is equals to epsilon naught A upon D minus T. D minus T is the space which is air, which is the width of the portion in which the air is there, and rest is the T by K. So T is the thickness of the slab, dielectric is K. So now here if I put these values, what we are getting, epsilon naught A upon D minus T. Since the width is D by 3, that means the remaining distance will be 2D by 3. So directly I can replace this thing as 2D by 3 plus thickness is D by 3 and dielectric constant is 3. And we can solve it. So it is 9 is LCM. It is epsilon naught A by 7D, which is 9 by 7 into C. So the correct answer is D. All right. So again, direct question based on the definition. No thought process, no multi-concept question. Okay, now this belongs to 11th, rotational motion. And again, rotational motion is the toughest chapter said to be for the student, but this is again direct question based on the properties of moment of inertia. So as you can see that there are two laminas which is uniform rod. So I will make them as a part of, I will consider this lamina as a two parts. One is this vertical rod, one is this horizontal rod. Vertical rod and horizontal rod. And since you have to find out the moment of inertia about this axis which is perpendicular to the plane. So what is the property? That to find out the moment of inertia about any of the axis, this you can consider as the combination of the two bodies 1 and 2. That means I need the moment of inertia of 1 about O, and I need the moment of inertia of 2, the second portion about O. For the first portion, this axis becomes the axis which is passing through the end. So directly we can write down this thing as ml square by 3. But for the second portion, we have to apply parallel axis theorem also. So that's why for second, this is your ICM plus this is your MD square. Right? So for the second portion, we can write down this moment of inertia as ml square divided by 12, that is your ICM, plus MD square, that is your ml square. So now this is also the moment of inertia of the second body about the same axis. And as the property, we can add and subtract the moment of inertia only when they are about the same axis. So now this will be your overall moment of inertia about O of this combined lamina, if I consider this as a two parts of the body. So when you solve this, you are getting 12 is LCM, ml square. Now this is 4, this is 1, this is 12. So you are getting 17. So the correct answer is a 17 by 12 ml square. All right. Let's move to the next one. Okay, again from 12th. Now this question belongs to photoelectric effect. But this is little tricky because they are talking about generally in photoelectric effect. The concept is what? Like the photon is incident, photon energy will be absorbed by the electron, and as a result electron is coming out, so we will find out the kinetic energy. But the case which you have studied, in that case always you consider the light as a monochromatic, means with a unique lambda or with a unique frequency. Here in this question, they have given you the electric field of EM wave as a bichromatic because it is having two frequencies. So as you can see that they are having two frequencies. You have first frequency, first omega 1 as 3 into 10 to the power 14, and you have omega 2 which is 12 into 10 to the power 14. That means this is corresponding to frequency F1, this is corresponding to the frequency F2. So clearly you can see that in this photoelectric effect there are photons which is incident, which is having two energies. And since I am interested in maximum kinetic energy, so I will be interested in the energy of the photon of maximum energy. And as you know that if F2 is greater than F1, then the energy which is corresponding to F2 of the photon is more than E1. So which means that Ke max which you are getting for the emitted electron will be corresponding to E2 minus work function. I'm not saying that E1 is also capable to eject out the electron, but they are not having the maximum kinetic energy. Which is having the maximum kinetic energy, which is corresponding to the photon of frequency F2, which is being emitted by this photon which is having the frequency F2. So now it's simple calculation. So what we can say, omega you know, so you can find out the frequency. So this is H into F2 minus work function. The work function is given to you 2.8 eV. Now here, if I put these values, it is 6.63 into 10 to the power minus 34. This F is 2 pi, omega by 2 pi. So it is 3 into 10 to the power 14 divided by 2 pi. But this I need it in EV, so that's why I have to divide it by E also. 1.6 into 10 to the power minus 19 minus 2.8 eV. So this is how you do the calculation for this question. All right. Now you calculate this, you will get something around 4.96. So this becomes 4.96 eV minus 2.8 will give you 2.16 eV. Is your correct answer for the maximum kinetic energy. So this is a moderate question because they are using the concept of bichromatic light also. Okay. Move to the next question. Again, the next question is from 11th, class 11th, Bernoulli's equation. So it's a principle which you do in the application of Venturi meter, so direct application. So as you can see here, if I discuss the concept, there is some pressure P1, there is some pressure P2 which will be measured by the difference of this column. So if I apply the Bernoulli's equation, simply it will be P1 plus half into rho into V1 square is equals to P2 plus half into rho into V2 square, correct? Because this is lies horizontally, so there will be no rho GH term. For this P1 minus P2, or for this pressure difference P1 minus P2, which is half rho into V2 square minus V1 square, this P1 minus P2 you can measure by this difference of the vertical columns. So this will be giving you as rho GH. Rho GH is equals to half rho into V2 square minus V1 square. This rho and rho cancel. And that's why V2 square minus V1 square, that will be equals to 2GH. Now, the second equation which you are using is A1 V1 is equals to A2 V2. That is equation of continuity. The ratio of A1 by A2 is given to you as 2:1, because as you can see that A1 by A2 will be 2:1. All right. These values are different. These values are not correct. Again, as I told you, this is memory based, so some of the values are different. Let me give you the correct values here. So the value of A1 and A2 is given to you as, at A it is given to you as 6 meters square, and at B it is given to you as 3 meters square. So the ratio is 2:1. So So since this is 2:1, this is giving you 2V1 is equals to V2. That means I can replace here V2 as 2V1 whole square minus V1 square, that is equals to 2GH. Now substitute these values. So 3V1 square is equals to 2GH. This way you are getting V1 as under root of 2 into 10 into 5 centimeter, which is 5 by 100 by 3. This is giving me 1 by root 3. And since they are asking the flow rate, so for the flow rate Q is equals to, I can use A1 V1. Now since A1 is 6 meter square and V1 is 1 by root 3, my answer is going to be 2 root 3. So 2 root 3 is the correct answer for this question. Alright. In almost all the questions here, rho is given, that is the additional information which is not needed because rho GH is cancels out. So as you can see that till now we are directly getting the question which is directly based on the application or single formula based. There will be no twist, there will be no logical thinking which is needed more. If you know the basics, then also you are able to solve these questions. So till now it is going very easy to moderate only. Some of the questions like this alpha particle, there you need some calculation. So obviously this is expected, right? So few questions are definitely needed some calculation, means they are little lengthy. Rest is going according to the expectation. Okay, move to the next one. Again, this particular question, there are same issue of the language. So there will be two different languages are floating in the according to the student. So I will discuss both of them. First, whatever is written, like an ideal solenoid is kept with its axis vertical and current is flowing in the solenoid. If Q charge is thrown downwards inside it, what will be the acceleration on the charge? So first let me do this question, then I will discuss the another version of this question. So suppose if there is a solenoid, and this solenoid is having the axis vertical and the current is flowing in this, so whatever is the magnetic field, that will be also vertical. Now suppose when the charge is thrown downwards, if the charge is moving downwards, clearly you can see that the magnetic field and the velocity of the charge both will be parallel. And as you know that magnetic force on a moving charge is Q into V cross B. That means for the parallel direction, this force becomes 0. That means because of this magnetic field of the solenoid, there will be no force acting on the charge particle. So it will not affect the acceleration of this charge particle, and that's why acceleration of this charge particle becomes G. Since I am giving the benefit of doubt, so according to some student, this will be interpreted in the different way. So what will be that? The second version of this, that there is a solenoid, they will say this, there is a solenoid and there is a magnet which is being falling. So suppose if it is fallen and there is a solenoid, again if this solenoid is placed in this way, nothing will happen. But suppose if it is forming the closed loop, then as you know that when the magnet will be passing through it, it will form the opposite polarity. According to Faraday's laws, it will always oppose the change. So by the magnet, since the flux associated with the solenoid keeps changing, so to avoid it, there will be opposite polarity will be formed, right? And because of that, there will be a magnetic force experienced by this magnet. And because of this extra force, the acceleration is clearly less than G. So since we are not clear about this language of the question, if the language is like this, answer will be equals to G. But if the question will be different, like a magnet is passing through the solenoid, which is forming the closed loop, then your answer will be less than G. Okay. But still, this is the type of question which you did in the study material and in the classes many times. So very frequently very familiar question to you and simple question. Okay, let's move to the next one. So this time you will see that there is a lot of EM waves are there, and again there is another question where we are getting the direction of electric and magnetic field they are talking about. So if I say 12th portion seems to be like having more weightage in this particular shift. So here you can see, like when we are talking about EM waves and the propagation, this is omega t minus kx. So clearly you know that when the minus sign will be there, what it is interpreted, that it is moving in the wave is propagating in the positive, and this is omega t minus kx. So the direction of propagation is along x-axis, and since minus sign is there, so it is along positive x-axis. That means you get that if this EM wave is moving with the speed of light, then its direction will be c cap will be along I cap. Second, this electric field is given to you as 69 sine of something into j cap. That means the direction of E is also you are getting as j cap. Direction you are getting, so direction of C you are getting as I cap along plus x-axis. That's why it is I cap. And the direction of E, as it is given j cap, so it is along j cap. Now we have to find out the direction of magnetic field. So again, pure definition, that for the direction what you used to do, the direction of C is given by direction of E cross B. Up here, if this is I cap, this is j cap, then clearly what should be the direction of B? It should be k cap, because j cross k is I. So what should be my right answer? The correct answer will be option A. All right. Absolutely, again direct question. Okay, now this question is little lengthy because calculation is required in this, but conceptually it is easy only because they are simply asking the standard formula, which is the formula of expansion. So you know that how the longitudinal expansion happens. It is L equals to L naught 1 plus alpha delta t. Now since there are two rods which will be combined end to end, and they are free to expand, that means this will be expanded to some L1, this is expanded to some L2, and initially both the lengths are same. L1 is equals to L2, which is equals to 60 centimeter each. This is expanding with the coefficient of expansion alpha 2, alpha 1 and alpha 2. So if I say what will be my final L equivalent, it will be L1 dash plus L2 dash. That will be your L1 1 plus alpha 1 delta t, and L2 dash will be L2 1 plus alpha 2 delta t. Now since L1 and L2 both are same, which is 60 centimeter, okay, since the answer is also they are asking in centimeters, so I am not going to change the units. So it is 1 plus alpha 1, your delta t value will be from 30 to 100, that means the change is 70. You don't need to change the unit also, because change of the temperature you don't need to convert into Kelvin. If it is absolute, then you need to convert, otherwise delta t is fine. And this is also 61 plus alpha 2 into 70. So now for simplify the calculation, you can take these terms 60 plus 60 together, that is your 120 plus, here if you see, then 120 into delta t, again this 120 into delta t, if I took it common from the second and fourth equation, I am getting alpha 1 plus alpha 2. So now alpha 1 and alpha 2 is given to you, just simply add them, and by adding them and solving, we are finally getting this answer as 120.1512 centimeter. All right. Okay, guys, let's move to the next one. Okay, this is the first question from heat. Find change in the internal energy of the gas as its temperature changes by 10 K. So, mind, this is not the absolute, this is given change. So, change is given in Kelvin or degree centigrade, doesn't matter. So, directly you are getting what? Delta T. The delta T value is given to you 10. Either it is in Kelvin or degree centigrade, doesn't matter, right? Number of moles of the gas is 10. So, number of moles is given to you 10 moles. Now, Cp is given to you 7 calorie. And R is also given to you as 2 calorie per Kelvin. So, they are asking change in internal energy, and change in internal energy is nothing but NCV delta T. You very well know, if I know Cp and R, how to get Cv, because Cp minus Cv is equals to R, and everything is given in calorie. So, I am not going to change its unit. I will simply write down 7 minus Cv is equals to 2. That means Cv is equals to 5 calorie per Kelvin per mole. Substitute this value here. This is 10, this is 5, this is 10. Your answer is 500 calorie. They are asking the answer in calorie, that's why we don't need to convert it into joule. And directly we are getting the answer. So, again, a moderate question. In fact, easy question, I would say. Okay, let's move to the next one. Okay, so this belongs to the wave motion in a string. And this is a combined string. So they are saying two mechanical waves of equal length. Two mechanical waves of equal length are joined together, having linear mass density mu1 and mu2. Having linear mass density mu1 and mu2. Find the ratio of the time taken for a wave pulse to travel from one end to the another. Actually, in this question, this diagram is given to you. So, by the language, it is not, but it is connected together. That's why, if the tension in this portion is T1 and the tension in this portion is T2, clearly you can see that T1 has to be equals to T2. The tension cannot be same if this combination will be in equilibrium. Obviously, at any point, this tension has to be same only. So, T1 equals to T2. So, in both the string, tension will be same. The length is already given to you L. So, now suppose if a wave pulse is traveling here, then it is taking T1 time to cross this string and T2 time to cross this string. That means you know that for time, what we can say, distance divided by velocity, and the velocity of a wave in a string will be given by under root of T by mu. That means this value will be L under root of mu by T. So, to find out the time ratio, you can clearly see both the lengths are same, both the tensions are same. That means it is directly proportional to mu1 by mu2. And mu1 by mu2 is given to you 1 by 2. That's why my answer is going to be 1 by root 2. Option B. Alright. So, this diagram is given. That's why we can take the tension same and both the lengths are same. So, pulse is traveling with the time ratio 1 by root 2. Okay, now this question belongs to first question from gravitation. And they are asking that there is a satellite, which is, suppose this is a planet and satellite is revolving around some orbit of radius r1. That means this satellite and this planet, they are associated with kinetic energy plus potential energy. So what is the expression of writing down the total energy? It will be Gmm divided by 2r. Okay, so kinetic plus potential will give you minus Gmm by 2r. If you want to transfer this satellite from this orbit to some another orbit r2, that means what is the work required or what is the minimum energy required? So you can say whatever is the difference of the total energy of these two orbits, that will be the additional energy required. That means I can say that it is E2 minus E1, which is going to be GMM. Okay, if I compensate the minus sign, I am getting 1 by R1 minus 1 by R2. All right. So this is going to be GMM by 1 by R1. Now R1 is given to you 1.5 and 2 is also there. So this is 2R1, this is 2R2, right? So 1.5 R into 2, that is 3R, and R2 is 3R, so this becomes 6R. That means this is giving you GMM by 6R. And since you have to compare with GMM by lambda R, okay, again mistake, this is XR or lambda R, otherwise make it lambda. So GMM by lambda R, and then you have to find out the value of lambda. So simply by comparison, you can get the answer as 6. All right. Simply you are getting the answer as 6. Okay, move to the next one. So now the last 4 questions are little lengthy. Like calculation wise it is lengthy, not concept wise. Concept wise still they are using the single concept, not the multiple concepts. But yes, few problems we are getting which is needed little calculation. So here you can take the time. Still, I believe that whatever questions are coming, they are very well in the range of 1 hour. Means during this 1 hour, you will be able to solve all the question maybe between the range of 40 to 45 minutes. Because only 3-4 questions you will find out lengthy, not much. Or if I will say, still there will be a scope of 5 to 10 minutes which you can save from this 1 hour. Not very lengthy. And since they are directly definition based questions, so that's why. Okay, move to the next one. Okay, it belongs to 11th class, error analysis, right? And simultaneously also combination of springs. So it means force also. So it's a combined one. So if I am talking about parallel, so springs are in parallel. Springs in parallel means what? How to give its equivalent K? It will be K1 plus K2. Now your K1 value is given to you 20 plus 0.2. That means if I calculate K1 plus K2, it is 20 plus 30, which is equals to 50 newtons per meter. Also, you know that when Z is equals to A plus B, how to add their errors? Delta Z is equals to delta A plus delta B, means here delta K equivalent is equals to delta K1 plus delta K2. So K1, delta K1 is 0.2, delta K2 is 0.3, which is giving you 0.5 Newton per meter. We have to find out percentage change. So for percentage change, we can say it is delta K equivalent divided by K equivalent multiply by 100 gives you 0.5 into 100 by 50, which gives you 1%. So what is the percentage error in the equivalent spring constant? That is 1%. 1 is the answer for this question. Okay, let's move to the next one. Okay, YDSC wave optics. Okay, YDSC wave optics. Okay, so in a YDSC setup, a slab of width T is inserted in front of one of the slit. Okay, let's make it the setup of YDSC. So 2 slits are there. This is the central line. This is the screen. Generally, the central maxima will be here, right? Because the path difference for this is 0. But if you introduce a transparent slab, then this central maxima will be shifted. This central maxima will be shifted towards the side of transparent slab. The reason is this is producing the additional path difference, which is also called optical path difference. And how much is that? That is equals to mu minus 1 into T. So the additional optical path difference is associated with the wave 1 for this point, which will be compensated by the geometrical path difference, which is associated with this as 2. So when I say what is the overall path difference, you will say it is optical path difference minus geometrical path difference. Why I am talking about geometrical path difference as minus? Because this is associated with S1, this is associated with S2. And for the central maxima, I need it as 0. That means this optical part difference should be equals to this geometrical part difference which is created because of the position. So this you can write down as mu minus 1 into t. That is your optical part difference because of the transparent slab. And this geometrical part difference corresponding to this y will be given by yd by d. Alright, that's why this t you can write down as yd by capital D mu minus 1. Now substituting all these values, what is pattern is shifted by 0.2. So y value is 0.2 centimeter. Small d is 1 mm, that is 10 to the power minus 3. Capital D is given to you as 50 centimeter. That means 1 by 2 centimeter 10 to the power minus 2 into mu minus 1, that is 1.5 minus 1. So here clearly you can say that it is coming 8 into 10 to the power minus 6 meter, which is 8 micrometer. 8 micrometer. So this is micrometer. You have to find out the value of n, which becomes 8. All right. Okay, let's move to the next question. So I would say this question is moderate. Like YDSC, they ask the basic principle of the YDSC and shifting of YDSC, which is this type of question you often done in the class very frequently, right? So very familiar question, but obviously moderate question. And little bit calculation is also there. So I will put this in the category of moderate. Okay, let's move to the next one. Okay, from optics. Optical instrument. Okay, so optical instrument and focal length of the objective lens and eyepiece is this and this. Tube length is okay. So when tube magnification of compound for normal adjustment so directly formula based from NCERT, you know that magnification in case of compound microscope, that is given for normal adjustments as tube length divided by FO. Okay, direct definition given in NCERT. And normal adjustment, that's why D by FE. Magnification of objective, magnification of eyepiece. So if I put these values, it is 26 by F0, that is given to you as 1.25. And minimum distance 25 centimeter divided by 5. Calculate this, it is approximately some 104. Okay, these values can also slightly different because some of them are telling this tube length is 32 centimeter like this. So different values, but yes, directly what you need to understand the concept which we are using, the magnification of compound microscope for normal adjustment. If it is the least distance, if the vision will be at the least distance, it becomes 1 plus D by FE, right? That is the only change. But since they are talking about the normal adjustment, that's why direct formula is there. So again, super easy question, very easy question is this. Okay. So these are the some questions which we are discussed here. Some more questions are also there, which we received from different student. One of the question I would like to discuss here, one more question. A collimated beam, I will write down a collimated beam of light is having the diameter D1 2 millimeter, is propagating along the x-axis. Okay, let me make the diagram. The beam is required to expand in a collimated beam of diameter 14 centimeters. So what they are trying to say, that there is a beam of light which is 2 millimeter, and this they want to magnify it to the wider beam of the diameter 14 mm. So this diameter is given to you 2 mm. This beam diameter is given to you 14 mm. and they just want to do it with the help of two convex lenses. So one convex lens is here and another convex lens is, let us say, here. All right. The focal length of the first one is given to you. Second, we have to find out. The focal length of first is given to you as 40 mm. And second, we have to find out. Options are given to you as 270 mm, 280 mm, 260 mm, and 290 mm. Okay, so parallel beam. So when it is a parallel beam, then definitely where it will focus? It will focus at the focal length of the secondary focus of the first lens. And if it is at the primary focus of the f2, then it becomes parallel after that. So your diagram will be, the correct diagram for this question will be like this. This value will be your f1. This value has to be your f2. Then by symmetrical triangle, these angles will be different. These angles will be same as the symmetrical angles are there. Symmetrical triangles are there. So I can write down, if I named it as D1, if I named it as D2, then clearly by the property we can write down that D1 by F1 is equals to D2 by F2. So to get this F2, we are directly getting F1 into D2 by D1. Now this will be 40 mm, this is 14, this is 2, so this is 7, so 40 into 7 gives you 280 mm. That will be the answer of this question. Alright, this is the answer of this question. Let me see if any other question which is uncovered or important. Okay, there is one more question is given. A figure is given to you in which we have one resistance which is connected to a frame and a sliding wire is moving with some velocity v in a perpendicular magnetic field. So very familiar question again. We have to find out how much force we needed to pull this sliding wire with constant velocity. This force we needed, and everything is given. This resistance is given to you 2 ohm, this magnetic field is given to you 4 Tesla, this length of the wire is given to you 2 meter, and this velocity is given to you 15 meter per second. 15 meter per second. So to find out this force, we can use BIL. And what is I? I will be the induced current, which will be because of motional EMF divided by R. If I substitute this value, this expression will be V square VL square divided by R. Now substitute these values, so it is 16 into V. V is 15, L is 2 square, that is 4 divided by 2. So answer becomes 480. Okay, 16 into 30 is 480. So this will be the answer of this question. Fine. So some values can be changed. Some values can be changed. Okay, because it is a memory based question. But overall we have discussed, and this discussion, the question, the type of question which is coming, they are very well in the theme of the previous year. Means this year they have not given you something which will be surprising, just like the last year NEET paper, which is very surprising from its regular pattern. But this pattern is exactly the previous year's pattern which they are following. and this particular paper I will keep it in the easy to moderate category. As far as the shift 1 cutoff is concerned, okay, let's discuss this question. This belongs to electrostatics plus conservation of energy. So here you see the charge Q1 is equals to 10 to the power minus 6 coulombs at origin. Another charge 2 microcoulomb is taken to A. So let me write down these values. So first one charge is placed. What is the charge? The charge is placed at the origin. This charge is say Q0. This is having the value 10 to the power minus 6 coulomb. Whereas there is another charge Q which is 2 into 10 to the power minus 6 coulombs. It is moving from some position A to B. A to B. Now the coordinate of A is given to you. So coordinate of A is given to you as 4, 4, 2 and 2, 2, 1. So A is 4, 4, 2 and B is 2, 2, 1. Now they are asking what is the work done to do so. What is the work required to move this charge from A to B? Of this question, we can find out the force, then we can integrate, and then we can F dot dx, we can get the work done. Otherwise, the simplest method is to get by conservation of energy, or we can say work is nothing but change of energy, which is equals to Q into delta V. This Q is the moving charge, this delta V is because of this stationary charge which is placed at the origin. So if I put these values, it is Q into, this is VB minus VA, potential at B minus potential at A. Okay, provided that this charge is moving slowly, so that it is not gaining any kinetic energy. So clearly they have mentioned that another charge is taken from B to A, they should also mention it is slowly. Since it is memory based, so this particular information, I hope that is given in the question. Okay, so here if you see VA minus VB, which you can write down as Q into, this is KQ naught, which is coming common while writing the potential. This is RB minus 1 by RA. Alright, KQ by RA is VB, KQ by RA is. So if you calculate the position of RA and position of RB and magnitude of that, then this RA will be given by under root of 4 square plus 4 square plus 2 square, that is root 36, which gives you 6, and RB will be under root of 2 square plus 2 square plus 1 square, that is 9, so it is going to be 3. So I substitute all the values. It is 9 into 10 to the power 9, it is 2 into 10 to the power minus 6, it is 10 to the power minus 6. RB is 1 by 3 minus RA is 1 by 6. So this is 18, this is 3 into 10 to the power minus 3 joules, right? 3 into 10 to the power, 18 cancel, 3 into 10 to the power minus 3 joules. Okay, is the right answer for this. Okay, again some mistake in the values. I think this power is given to you as 10. This is minus 10, so you get correct answer as 3 into 10 to the power minus 7. But the concept of this is that we have to do it by change in energy. Change in potential energy is equals to work done if the charge particle is moving slowly from A to B. Okay, move to the next question quickly. A gas-based geyser is flowing with a rate of 5, is flowing water with a rate of 5 liter per, and it is heating from 27 to 87. What is the consumption? A very simple question. Just the flow of rate. So like suppose if you are talking about how much heat is required, and this heat is required in watt, that means per unit time. So heat required per unit time, that is nothing but that is dm by dt into s into delta t, ms delta t by t. So this dm by dt will be giving you energy per unit time. Now dm by dt is directly given to you 5 liter. In case of water, 5 liter is equivalent to 5 kg. When you multiply with the volume, then corresponding to this volume, What is the mass? Mass will be 5 kg. So I can say this mass flow rate will be, its mass flow rate will be nothing but it is 5 kg per minute. 5 kg per minute, minded, convert into second. So it is 5 by 60. 5 by 60 kg per second. So now dm by dt value will be 5 by 60. Sorry, as far as this S is concerned, it is 4200, okay, in joules, and this is delta T. So delta T is 87 to this. That means 87 minus 27 is 60. So this is cancels out. You are getting 21,000 watt, which is 2.1 into 10 to the power 4 watt. So what is the value of X? Becomes 2.1. All right. So this is your next question. Move to the next one. Okay. This is a good question. A particle of ring of area 1 meter square and the resistance 100 ohm is in the magnetic field B. Okay, so this is a variable field passing perpendicular to the ring. Find out the heat produced in one time period in joule. Okay, interesting question. I will just collect the values and then I will explain to you. So there is a ring. There is a ring which is having area 1 meter square, and this is placed in a perpendicular field. This is placed in a perpendicular field. B is equals to sine 100t Tesla. Sine 100t Tesla, and resistance is given 100 ohm. Okay, so B is given to you sine 100t Tesla, and its resistance is also given to you as 100 ohm. They are asking what is the heat generated in one time period. For this particular question, you can see that this magnetic field will be responsible for associated flux, but since this field is also variable, so this flux is also variable. And when the variable flux is there, you know that by the variable flux there will be an induced EMF according to Faraday's law. So if I say what is the induced current, that induced current will be E induced divided by R, which you can write down as area into dB by dt by R. All right, area into dB by dt divided by R. This is because of change of field, which is dB by dt, and if I say dB by dt is how much? It will be 100 cos of 100t. So this current which is flowing in this circuit, this will be producing heat. So for the heat, it is I square into R into dt. All right, I square R is the power into dt, and since they are asking for one cycle 0 to t, so I can write down that this value will be A into dB by dt by R whole square into R into dt. Okay, there is a trick to solve it. That we can write down these values as 0 to t, area is 1, so 1 square into dB by dt, that is 100 square cos square 100t divided by R. 1 R cancels, so 1 R, so that is 100 into dt. This 100 cancel. This is cos square dt. You don't need to solve it because they are asking for one cycle. That means you can take average value of this. If I take the average value of this, clearly it is t by 2, means 1 by 2. So if I divide it by t, multiply by t, the average value of cos square 100t in one cycle, that is going to be 1 by 2. So it is 50 into t. 50 into time period. Now how to write down the time period? Time period is 2 pi by omega. Omega is 100. That's why clearly your answer is pi. Okay, 100 cancel, the answer is 5. So quite a good question, moderate question as per this, and nice question on Faraday's laws, EMI. Move to the next one. Okay. This question is memory based, so it is given in different sources. It is given different, but this is the more accurate, which I assume. So let me discuss this. So in this question, this question belongs to variable acceleration. So it's a good question of kinematics. Acceleration is given to you, and we have to find out the velocity and position as a function of time, right? It is starting, initial position is origin, and initial velocity is also 0. So let me write down this acceleration expression. A equals to t cube I cap and 3t by 4 j cap. Okay. So A is equals to t cube I cap t cube I cap 3t by 4 j cap minus 3t by 4 j cap. Obviously, we can write down this as dv by dt. That is t cube I cap minus 3t by 4 j cap, and get the velocity. This term will come with I cap, and this 3t by 4 dt, this term will come with j cap. So final answer is t to the power 4 by 4 I cap, and this is 3t square by 8 j cap. That is the velocity. Initial velocity is 0. That's why this is your velocity expression. Same way, if you differentiate this again, integrate it again, what is R? R is v dt. Okay, v equals to dv by dt, R is v dt. So it is t to the power 4 by 4 dt. This is with I cap, minus 3t square by 8 dt. This is with j cap. That means it is t to the power 5 by 20. Okay, by 5. 4 into 5 is 20. This is with I cap. Minus, this is t to the power 4 by 4, which is 3 by 32 into t cube. This is with j cap. So these are your corresponding position and velocities, right? T to the power 4 by 4 and 3 by 8. T to the power 4 and 3 by 8 and t to the power 5. Okay, we can simplify it more, no? T square by 8 are okay. So 3 by 8, t cube by 3. Okay, so 3 cancel. So 3 cancel here. 3 cancel. I multiply by 4. This will come. 3 cancel. It will come as 8. All right. T cube by 3 cancel, it will be coming 8. So t cube by 8. Alright, and that's why the correct answer is t to the power 5, t cube by 8, and t this. Okay, first one. Right? Okay, move to the last question. Last question. Okay. Nice question is this. Though it is very straightforward, but looking like horrible because inequality is given, graph is given, so sometimes the students are getting afraid of this type of question. But if you see, this is the graph of potential energy versus x, and they are talking about the magnitude of the force. That means if I purely go by the definition that force is nothing but it is minus du by dx. That means the magnitude part of the force I can directly get by the slope of ux graph, and in the slope also we have to see the slope only magnitude part. That means for the portion AB, what is the slope? So you can find out this tan theta, which is 1 by 1. That means this is coming 1. Similarly, what is the slope of BC? It is coming as 5 minus 1. Can you see that? 5 minus 1. This is 5 minus 1. That is 4 divided by 2 minus 1, 1. So it comes as 4. Then force across CD is again given by the slope of this line, which is 0, and slope of D to E, that is given by the magnitude of the slope, which is 5 minus 3 upon 7 minus 5. So 5 minus 3 and 7 by 5, 2 by 2, which is 1. So clearly now you can see that here force across, for the region CD is least, then force across AB, which is also equals to force across DE, and the greatest one will be across BC. across BC. So BC is greatest, CD is least, and they are equal. So correct answer is first one. All right. So this is the end of the discussion. So thank you very much. Hope you did well. And for the student, those who are appearing in the coming session, all the very best. Okay, don't worry. The pattern is absolutely as per the expectation. Just keep your cool maintained. Don't lose your temperament during the exam. Easily you can score very well during this JEE exam. Okay, very best.